Guys, in this video we are going to see an example on how to find the limit of a multivariable function and how to find whether the limit does exist or does not exist. Now if you want to do this problem, first of all, if you remember that first semester calculus, you had 2D space. For example, you had xy axis, and to find whether the limit exists or not, you had a value that approaching from the left side and from the right side, right? When we have limit approach from the left side and the right side, and if both of them are equal, then limit exists, and if both of them are not equal, limit does not exist. So we usually express that one like this: when x approaches a minus f of x is equal not equal to limit x approaches a plus f of x. If this is not equal to this, then limit does not exist. So here in this three-dimensional space, we are going to use the same thing. Like what we are going to do is we are going to look at the three-dimensional space, and here the difference is in two-dimensional space you only consider left side or right side, but in three-dimensional space we have to look at all the sides. There are multiple possible ways. It can be like this, it can be like this, and we have to have the limit approaching the same value. And if you don't get same value in any way, it means the general limit does not exist. Now this is what we are going to do right here. Let's look at this one in two-dimensional space. So if you draw this one in two-dimensional, for example, if you take a value that approaching this 0, since our question is about 0, xy approaching 0, 0. So if this is approaching origin from this y-axis, and if this is approaching origin from x-axis, and if both of them are not equal, it means limit does not exist. And if it is equal, you have to try multiple different ways. And if you find, for example, if you find the same values again and again and again, then you have to use another method to completely prove that limit exists, right? Here this one is does not exist, but let's see how we can find it. First of all, what we do is we find the limit along the y-axis. So to do that, what we do is we take this limit x, y, and along the y-axis. So when we take along the y-axis, what's going to happen is we keep this x is equal to 0, right? X is 0, y is going to be like this, and this is approaching 0, 0. Now when x is equal to 0, what we can do is in the equation, in the original equation we had x power 4 x square. We are going to directly put the 0 right here, right? Then we are going to find the limit. Now if we plug 0 for this x and this x, we are going to have the value that's going to be negative 4y square over 2y square. And from this one we can see that y square cancels, and finally we will end up with negative 2. Now since we don't have anything, we are getting a constant, so that's going to be our limit when we take the limit along the y-axis. Now let's see what is the limit along the x-axis. Limit along the, so this is along the y-axis, this is along the x-axis. Along the x-axis, what we do is we keep x as it is and make y is equal to 0 and approaches 0, 0. Now here we plug 0 for y values, and we are left with x power 4 over x square, and that's going to be equal to x square. If you simplify this one, that's going to be equal to x square, right? X square, but we have to put limit right here, right? So we have to put limit because since we are getting a x value, we have to apply the limit. So limit x0 approaches 0, 0 is going to be x square. Now if you plug 0 for this x value, that's going to be 0 square, that's equal to 0, right? Now we are getting 0, but previously we didn't apply anything because we didn't have any x value or y value, right? Here we have x value, so we have to plug this 0 for x value. Now from this one, now we can already see negative 2 is not equal to 0, therefore limit does not exist. And that's how we show limit does not exist for a multivariable function. I hope this helps. Thanks for watching.